Okay, we're looking at scatter plots today. A scatter plot has points that show the relationship between two sets of data. When we did height and arm span, that was our two sets of data. In this example that you look on to the left, each dot shows one person's weight versus their height. And it's plotted on an X and Y axis. There's a word I'd like you to write since we're talking about things that have two sets of data. The word bivariate. Well, bi means two. It means we're comparing a number to a number. Weight is a number, height is a number. Height is a number, arm span is a number. Looking at the next slide on your notes, you see a table. It says ice cream sales versus temperature. So we're talking about numbers again. Ice cream sales is a number, temperature is a number. We're comparing bivariate data. So the local ice cream shop keeps track of how much ice cream they sell versus the noon temperature on that day. Here are the figures for the last 12 days. And notice these are in Celsius, so it's not as cold as it looks. We're going to move on and look at the graph. Here is the same data as the scatter plot. It's now easy to see that the warmer weather leads to more sales. So as the temperature rises, the sales rise, but the relationship is not perfect, meaning it's not linear. But there's definitely a trend. So as we look at the next slide, we draw what's called a line of best fit, or a trend line. So notice both of those things mean the same thing. You try to have the line as close as possible to all points and as many points above the line as below. So try to have about half and half. And this one, as I look at this, it's going uphill, increasing. It's a positive trend or a positive association. Let's look at the next example, sea level rise. So you notice along the x-axis it has years, 1993, 1995, 1997, and then this, the y-axis is the sea level. So as the years have been increasing in time, the sea level has been rising. And then in the bottom graph, the line of best fit is showing that trend of rising. So as the years increase, the sea level has been increasing. Okay, this goes back, and this is again using the temperature and the ice cream sales example. Two words very important to know. Interpolation is where we find a value inside our set of data points. So here we use linear interpolation to estimate the sales at 21 degrees Celsius. So they've gone along the x-axis to 21 degrees Celsius, which was not a point on the data on the table. And then you rise up to the line of best fit, and I'm making a point right where they meet. So it probably would be about $480. That's interpolation. You're within the data. And then on the next example, there's something called extrapolation. Extra, outside of, is where you find a value outside of our data points. So here we use linear extrapolation to estimate the sales at 29 degrees Celsius. So there weren't any days in our data that were 29 degrees. The highest we had on there was 27 degrees Celsius. But looking at the graph, if we use the trend line and we assume the trend would remain, then as we go up, we see that it would probably be about $750. But I do want you to note this right here. Be very careful. Extrapolation can give misleading results because we are in uncharted territory. And what that means is if we go too high on the temperature where it's not feasible, we could sit here all day and name temperatures that we could extrapolate, but we have to also be realistic, and it could be misleading. Okay, and this was something we did with our arm span and height example. We can estimate a straight line equation from 2 points. So what they've done is try to find 2 points along that line of best fit to find the slope. They're finding slope a little bit different than we've done in the past. We have just been counting rise over run on our graph. It's the same exact thing. At some point we had written this down, change in y over the change in x. Well, how do we find the change in numbers? We subtract. So from the 2 points that they have picked, 12 degrees, $180 was 1 point. 25 degrees, $610 was another point. While the change in the dollar amount, $610 minus $180 is our rise of $430. The temperature change would be the 25 degrees minus 12 degrees, which is the 13 degrees there at the bottom. And then if you actually got on a calculator, because this would make more sense to us, go ahead and get the decimal and then rounded it. Okay, the word correlation we talked about the other day. I do want you to also add this to it. Correlation, association, trend. Same thing. So when two sets of data are strongly linked together, we say they have a high correlation, a high association. They go together. Correlation is positive when the values increase together, and correlation is negative when one value decreases as the other increases. So as one is going down, one is going up for negative. And here's some great examples. The perfect, the high positive correlation. This one's a low positive correlation because they're a little bit more scattered about, but we can still kind of see a trend. The one smack dab in the middle, no correlation. They're very scattered. There's no trend. The points aren't really going in any direction. A low negative correlation, you can kind of see it trending this way. This one will be a high negative correlation because those points are a little bit closer together, definitely going downwards. And then they call this perfect because it's linear, isn't it? Which graph shows the best line of, the best line of best fit for the scatter plot? Which graph shows the best line of best fit for the scatter plot?